the time, Dr. Pleus, so we can actually walk through any of the questions that you all may have. And it looks like with some notepads, you'll have a lot of them. So I will turn it over.
Can I just ask one thing?
Yes.
With what happened over right now in A, did any management, did anybody take notes?
Yes.
On questions that were asked, and that will be published so that our colleagues who are not here, and,
Yeah, we actually had
clear answers.
Yeah, Nicole Warner from our HR team was actually there, and she is one of our best note takers.
Okay.
So took a lot of notes on that. That way, we could answer any of the questions. So we also have Charlie Heaton here, who is also going to be taking notes for any of the questions that come up.
Because you have a lot of people who would like to be here, and then they see that you're here all of a sudden, and they're like, they would have driven here to be with you if they had known.
So we'll try to put some Q&A out, right? So once we
Right. And recognize there will be more opportunities. The report was just finished this weekend, and so while Dr. Pleus was here in Atlanta, we did want to provide an opportunity for whoever could recognize very short notice, but just know this won't be the last. And we will now have a little bit more time to actually get the visit out well in advance of just a few hours.
Okay.
I think you just answered it, but does that mean you'll be sending out an email to state where they'll be, what base, and when?
Yeah, full communication go out, whether or not we do an email, SkyHub, we're going to hit all the communication change, base locations, dates, times, etc. So that's something that our team is working on.
Right, and there is nothing, unfortunately, we've been doing on the go ever since this report was published. We do not have that schedule yet. So it was somewhat of a very kind of last minute to come over here. So I wish I had more answers on
So if there is travel, and we will publish that, yes.
Yep, absolutely. Thank you for being here.
Well, thank you for having me here, and thank you for attending. And how many have ever met a toxicologist before? One. What does a toxicologist do?
Red word?
That's what this is.
Girl.
I'm a little warm up.
Okay. Yeah. Yep. So I'm a toxicologist. I'll tell you a little bit about me and a company called Intertox, and then I'll talk about the study that we did, and I'll go through the study, knowing that you have some questions about the results, I suppose, but I think it's important that you understand how we did the work, because it gives you some understanding of the thought we put into the study, so to answer, I think, really important questions. So we'll do that. So I'm a toxicologist. I have a master's in public health. I have a PhD in pharmacology and toxicology. I'm not a pharmacist. I'm one of the people that were designing drugs for a period of time in my academic career, which gives me a lot of information on how chemicals work in the body, and so that's a big advantage. And I also know about therapeutic agents, so things like antibiotics or anti-anxiety chemical drugs and things like that. And then I have a postdoc, so I have specialized training in neuropharmacology, so how chemicals really affect the brain and the nervous system. That's one of my areas. But I also have a specialist in aerotoxicology, so for example, I'm one of two toxicologists that was asked by the U.S. Congress to look into the F-18 issues. They're called physiologic episodes, where the F-18 pilots, which are fighter pilots in the Navy, they fly the F-18, they were experiencing things that look a lot like hypoxia, which means low oxygen in the body. So I'm one of two people that's been working on that with a bunch of other medical people. I've founded a company called Intertox. It's 25 years old next year. And I have been practicing probably for an extra 5 years. I have about 12 people in my office in Seattle. Some people have worked for me for 20 years, but I generally have a lot of people that have been working for me for quite a while. So, Intertox is a company that does toxicology work. We are not a lab. I'll explain that a little bit more. We're not a lab, but we have worked for these types of clients, if you will. Nonprofit organizations, for-profit organizations, government. On the for-profit, we've worked for very large companies. Delta would be a large company for us. We've worked for companies like Lockheed Martin, or we worked for companies like Boeing or whatever. These are multinational corporations that we have provided similar services for. In other words, we address complex chemical exposures. So, and that's what we're doing here, is doing the same kind of work. So whether I've worked for the government or the foreign government, which I've done, or Delta, or a citizens group, or whatever, we've done a lot of work for the same types of questions. Does this chemical, or do these chemicals cause health effects? And that's our job. So, and what we say to our clients is, we're going to find out, and we're going to report what it is that's scientifically defensible. And if you don't, client, like it, that's not our problem. We're going to tell you what it is. So that's our commitment to the work that we do. What else can I say about Intertalks? I also come from a family that flies a lot. My grandfather in the 1940s flew. My dad was a bush pilot in Alaska. I soloed when I was 16, and my brother's in the Air Force flying F-35. So we have a aviation kind of interest in our family. So what else can I say? I've looked at chemicals, probably anything from water to chemical warfare agents. I have found agents that cause health effects. I've reported those. If you Google me, which you probably have, you'll find out that I have been in the news, and you will see other issues where I've been involved, or my company's been involved, where we are being asked to do scientific work, and that scientific work is reported. And just like my report, it's transparent. Everything we've done is available. The report that I submitted to Delta is about 1,000 pages long. You're not going to read 1,000 pages, but I'm saying it's there if you want it. Most of that is all the raw data that we collected, and I'll tell you how we collected that raw data. But it's transparent. It's there. You can look. You can send it to someone. They can look at it. Whatever you want to do, it's there. The way that toxicologists do their work, if you're trained like me, that went to a medical school environment. I'm not a physician, but I went through, so toxicology is a medical science. Not a lot of physicians have toxicology training, but it is part of a medical discipline. So if you've been trained like we have, or my brothers and sisters in this area, we have a process. It's not unique. It's not some mystical type of thing. We have a very specific process that we follow, and that's in the report that I have. I think that kind of gives you an idea. Did anybody have any questions about who I am, or does anybody Google me and wants a question to be answered, like any in that area?
Yeah, I found a lot of bad reports about you.
Yeah,
about you being paid a lot of money to lie to big companies' employees.
That's like the first thing that comes up.
Is it?
Yeah.
Yeah. What do you know what you're talking about?
One is in 2002.
In where?
2002. It talks about a company, a fuel company with something that starts with a P. I can't pronounce it properly.
Perchlorate.
Yes,
Yeah.
and how 37 people ingested it in 2 weeks, and that they got sick. But then when your firm was hired to test it, that it came back like inconclusive, that it wasn't really happening. And then an independent reporter went in and found that 2 of the authors of that were connected to your company, and that it was fabricated. That's
Wow.
like the first Google search.
Well, that is news to me.
And
so
I just did that when you said Google me.
Good. Well, I think I know what you're talking about, but it's all wrong that you're saying. But would you like me to respond to it?
Yes.
Okay.
Well, no. You just asked the question. I just wanted to tell you.
But I mean,
that comes up.
would you like to know what the
No.
answer is?
No.
Okay.
No,
I'd
we're
rather
more
talk about
concerned about
our
ours.
reports. I'd rather talk about our reports.
Okay.
Go
Good.
ahead.
As far as people, companies
Not at
that
all.
do toxic
Thank you, Beth.
How many big ones are there? I mean, there's your company, and how many are there to choose? Do you do other airlines typically? Did you do American or?
Yes, did American as well. I've looked at
Alaska?
No. You mean in terms of their uniforms?
Mm-hmm.
No, did not
So
do that.
Can you discuss the difference between what you've done for us versus what you did for American?
Sure. So, so American, one of the biggest differences, we designed the study for Delta, whereas the study for American, the company that makes the uniforms called Twin Hills, and they had done a whole bunch of testing they did the Okatech testing, which I'm going to talk about here as well. They did Okatech testing, and we used that data, which is literally over 300 chemicals that they had done. And we felt that they had done it in a way in the laboratories that were done, that had done that work, had done it well. And so we could make a decision to use that data set. So that's really the biggest difference. Delta here, we actually designed the study, and we used 3 different labs. One of them was Okatech lab, and then there's 2 others, one in Michigan and one in California. I can tell you more about that. And so that's a huge difference between the 2. We actually designed the study in this case and added more chemicals than Okatech normally looks at. And Okatech, if you're not familiar, is a worldwide system of standards for textile manufacturers and clothing manufacturers. And they have standards. They have a line. You can't cross the line, because if you cross the line, it's not Okatech certified, and that's what they use for safety. And so we use that same system. So there's a commonality, and everybody can have a trust in what that system is. So that's what we did. Does that help answer your question?
What lab did you use?
So we use the one in Germany, Hohenstein.
Where in Germany?
I don't recall.
Okay, because there is a company in Germany that has some doctors as well, and they have done the studies with Lufthansa.
With what?
Lufthansa.
Oh, with
Lufthansa.
Lufthansa?
Yeah.
Okay.
Yes.
I don't know. So Hohenstein, and there's other labs around the world that do the Okatech standard. If Lufthansa has done that, then they probably use the same lab.
I see.
Yeah. Because that's the only one in Germany that I'm aware of. I just don't know where in Germany it is.
Yeah, and I forgot the city too, but I have it somewhere here. Let's search for it. But probably just going off a bit away from what you're saying, I've spoken to a lot of the American Airlines flight attendants, and the problems seem the same or similar, very similar. We have a lot of problems, and I did see your email today, and I ran through it really quickly because I was commuting, so I really didn't get to read it quickly. However, what I did get from it is that there is no relationship between the uniforms and the illnesses.
Yeah. So let me give the results first, and then I'll tell you how I came up with those.
Can I interrupt?
Yeah.
I would like to know, and I think it could tie into the results. I'd like to know the process used in the testing.
Yeah.
Okay, because once I understand the process, because what your report didn't really give details, or at least not in layman's terms, so I would like layman's terms, what process was used in the testing, and then the results.
I think that's a great way to go.
Yeah.
So we started back in, I think, end of May, somewhere around that time. And there's a process that we followed. The very first process was, what do we know? So to find out what do we know, we asked Delta, and Delta provided us lots of information. They gave us the people that were having reported health effects, skin, and respiratory. So we got that data. I looked at a lot of pictures of rashes and things like that. So that was part of the data. We looked at, then contacted Land's End and said, we need to have some information. What do you have that we can use? What we asked for was we want all processing information, which meant this. So when you build a fabric like my coat here, there's the fabric itself. That's made in Asia. The fabric is kind of material like fiber plus other chemicals to make those fibers do what textiles do. We want that list of chemicals that you use to make those particular textiles. Okay? And then those fabrics go to another company, and then that company will take the fabrics and start making different parts of a uniform, like a dress or a vest or whatever. So there's another company that puts things together to make clothes. Sometimes they'll add other chemicals at that point. Those are usually performance finishes, and those performance finishes could be things like your clothes don't wrinkle as quickly, or there is a material that if you pour some liquid on it, kind of runs off as opposed to being soaked in. Those are performance finishes. Another one that I'll bring back up later is an antimicrobial agent. And that antimicrobial agent is because when you're wearing your clothes, some of them fibers, little bacteria really like. And so they'll actually, because your skin rubs off on it or whatever, they'll find a little house to live in, so to speak, in your clothes, and they will multiply because the clothes are kind of a source. So they add an antimicrobial to keep the bacteria levels down. So we pulled all that information to us. We also said, did you guys do any testing? So like with American's source was Twin Hills. They had done a lot of testing. We looked at Land's End. They said, yes, we've done testing. And I said, we need the data. So they gave us the data, and we looked at it very carefully. I called the laboratory that did the work. So Land's End gave me permission to actually talk to some of the scientists that were there. So we got some questions answered that we needed to have. But the end result is this. While the data from Bureau Veritas, which is the name of the lab that did this, looked good, it wasn't extensive enough for the chemicals that we wanted to look at in order to make sure that we're covering as many chemicals as humanly possible. Additionally, and you'll hear this, is that when we do laboratory testing, or we don't do it, but when we commission a laboratory to do it, we want to know that you can actually measure this in a way that's reliable, because I'm ending up trusting that data to make an opinion. So when you go to a hospital and you get your blood drawn, the physician there needs to make sure that that laboratory is giving him or her the data that they can interpret correctly, right? I mean, because if that value is off, it doesn't make any sense. So we asked these labs to give us not only the data, but what we call the Quality Assurance and Quality Control Pack, which is a whole bunch of new data that shows that the instruments are working as we had requested them and required them. Does that make sense? So we pulled all this data, Bureau Veritas, we said, okay, it's okay, but we don't have this QA/QC we want to have. We don't understand some of the methods that they used. It doesn't look like it's a problem, but it's not wide enough, and there's not enough data that I felt comfortable as a toxicologist to be able to make a risk toxicological assessment on. So we went back to Delta and said we need to test a lot more, and we need to test. We need to include the Okatech, and then we need to include 30 other chemicals that are not on Okatech, and we need to include chemicals that are emitting from the uniform as well. So what do I mean by that? So one thing is that, when you have fabrics on your skin, like my shirt is the closest to my skin right now. I don't have a t-shirt on, for example. It's the closest to my skin. And I'm interested in the chemicals that are in my shirt, because that's the first place we're going to get the closest chemicals to our body. Does that make sense? My jacket has to go, whatever any chemical there has to go from the jacket through the shirt to the skin. It's a little farther away. We did include jackets, blazers, for example, or vests, or scarves, or all the dresses.
Where did you get the uniform pieces from that you tested?
Great question. Land's End.
Was it the first lot?
What do you mean the first lot?
The initial lot, when we first got the uniforms a year ago May, the first initial fabric bolts that they sent out to make that first initial shipment of uniforms.
I don't know the answer to that question.
Because those are the ones that apparently had, so to say, formaldehyde applied to them to keep them from deteriorating prior to the time that they were then assembled.
Well, I'll tell you, some of the detections clearly are formaldehyde. We found formaldehyde in the textiles that we tested, in the uniforms that we tested. I'm going to tell you that right now. But I think so the answer is, the first lot, I don't know. I don't think so. We went to Land's End in June, and my staff went into the company, and we picked the uniforms. We didn't let Land's End pick it. We didn't let Delta pick it either.
Had anybody worn those? Did you test the uniforms of the people that were complaining?
Good question. And kind of the short answer, but I'll come back to it if I don't answer it at this point, is when you start wearing a uniform, you've added hundreds of new chemicals. Why? If you wash your uniform, the detergent now goes into it, and any fragrances that are in the detergent, or all the stuff that's in detergent goes right into the clothes. Even if you rinse it, there's still residual stuff in it. If you wear a
But
lotion,
is everyone using Gain?
Let me finish.
Please let him finish, because I really want to hear this.
Please let me, and then I'm going to answer your question, but I want to make sure I'm clear about something. So whether it's Tide or Cheer or whatever it is, it's going to stay. If you use lotion on your skin, that'll go into your uniform. If you use a fragrance, it's going to go in your uniform. If you put cosmetics on, it's going to go in your uniform. We've seen the results, and the number of chemicals skyrockets, not due to the uniform, but due to the contamination, if I use that word, of the daily products that people use, including walking through industrial, walking through an airport, or walking through your home, or whatever, all the things that could come on there. So the answer to your question is, what we did is we picked uniforms still in their bags. Why? Because when we pull it out, we're going to get the highest concentration of chemicals by absolutely brand new uniforms. The other part of that, as soon as you put your uniform on, everything starts to decrease in concentration. Formaldehyde drops, for example. So when you wear it outside, it's starting to drop. If you wash it, formaldehyde drops by 50% every time you wash it. So
you went back to Delta you wanted to do more testing. You went and got the uniforms from Land's End.
Yep.
And from there, how?
So then we took the uniforms.
So can you talk a little bit about the randomness of the pulling of the samples? Because I think
That's a given.
We know that. We understand.
That's a given.
Let's go.
That's typical testing.
Go ahead.
So go ahead.
Well, it is important though.
Right.
No, if you're going to go and pick randomly,
Yeah.
I mean, you guys did it. You didn't include anybody except for your team.
Yep.
So you're professionals. You know how to do it. Okay.
Great. That's great. But it's important.
I want to know, with all the things that you've just mentioned, we've been wearing clothes for years. We've had several different uniforms. We've never had this reaction. They get washed, you wear your perfume, you wear your lotions, the powders, whatever. But we have never had this reaction. Only since we've had this uniform.
Let me finish and we'll come back to your question.
I'm afraid I won't be able to finish much.
But my questions, I'm still waiting for him to finish answering that.
Yeah,
so.
yeah. I'm going to take it a little bit on a methodological, because I think this is going to help as well. So what we did is we brought them back to our offices, and we dissected the uniforms into pieces. Again, what does that mean? That's my blue blazer here. We separated the lining from this, and we tested this. We also did it in triplicate. Okay, that was important from a science standpoint. And then we sent it to 3 labs, one of 3 labs.
So the procedure, that's what I'm asking specifically. How did you test it? Did you put it into like an antigen form? How did you put it into to test?
Yep. I'll get to your question in just a second. So when you cut the pieces up like this, we required the laboratory to use chemicals to extract chemicals from the textiles. This is really important. They're like, and I use this as an analogy, these solvents and these materials are like little chemical magnets. And so what we did is these little pieces that were, not little, but they were certain size pieces, we sent to the labs, then they bathed them in those solutions for the ones in Michigan for 8 hours at body temperature.
They bathed them in the solvents or in their own chemical to extract?
In something called synthetic sweat.
Okay.
Which is nothing like your sweat. And what we added to the synthetic sweat was chemicals to draw, they were like magnets drawing chemicals out of the fabric. Why do we do that? Because we want the most chemicals we can get out of the fabric compared to what you would normally have on daily wear. So when I'm wearing this, unless there's some transport material between me and my shirts or my jacket, there's no way chemicals are jumping across that gap of air. You need a transport mechanism, and sweat is the best one. Okay? So that's the best way. Otherwise, they just stay in the fabric. Except for those chemicals that are emitted, which is a small group. It's not very many. It's a small group that can move into the skin. But then when it hits the skin is made out of 3 primary layers: epidermis, dermis, and subcutaneous tissue. This is the number one defensive part of the body, is your skin. And the epidermis has no blood flow at all. And it's anywhere from 8 to 15 cell layers thick. And so chemicals have to if they make it from the fabric to the skin, they have to go from the outer skin, transfer all the way into, and get to the bloodstream. It's a journey. Can it be done? Of course it can be done, but it's not that easy. And it depends on something called the dose. Okay? So what we did then is we bathed these things in chemicals to get the most. So remember, we picked brand new uniforms out of the bag, highest concentrations. We pulled the chemicals out of the fabric with solvents or synthetic sweat. And by doing that, we got the highest concentrations we could in all of the garments that we tested. And all the garments, I've already kind of named them. We focused, though, on those closest to the body. Like, we didn't do overcoats, like winter coats or anything like that. We did everything that's close to the body, including jackets and vests and things. Does that answer your question, Laura?
Okay, that's part, and then what do you do then with that solution afterwards? Because I'm assuming you're using the solution to further test.
Yeah, it pulls the chemicals out, and that's what we test is the solution, which is the standard way of doing this.
Okay.
Yep.
Richard,
Yeah.
I have a question that
Yeah.
just to clarify the process before this. You say you took 3 samples
Of the same garment.
of the same garment
Yeah.
per lab, so they all got the same samples from the same garment.
Yes.
And the garments were sourced from Land's End. Did you know whether they came from China or Sri Lanka or where the source was?
Well,
or was that part of the randomize?
So there's a part of this that I don't know. So if I look at your uniform, there's parts, or I'll use mine. I don't know what's right here. Let's say the lining comes from Sri Lanka and the jacket comes from Vietnam. I think we could track back to see what that is, but we didn't track it per se on the location of the origin because we were getting detections on it on a lot of things. We got chemical detections on a lot of items. I'm going to get to what that means in a second. But so the answer is I didn't track it back to us particularly. We also looked It raises an interesting question, because when we first got the data from Delta on people experiencing reactions, a couple of things were right off the bat what we wanted. Is there one part of the body that everybody's complaining about?
Yes.
And the answer is no.
No.
Not
So
just one, but there's one main one. We all get purple armpits.
Okay, we'll get to that.
Yeah.
You hold on to that question.
Every single one of them.
I did not.
So,
Wear the dress?
Stop.
I'm sorry, I'm getting.
Sourcing. You're talking about.
Okay, so you were
Flight attendant Pamela Locker.
you got
here in the
chemical
lounge.
detections
Please
from
come
all
to
the
desk.
pieces.
Pamela Locker,
She
here in
asked
the
you
lounge.
about,
Please come
did
to
you
the
care
duty desk.
about where it was from, and you said you did not trace it back because you were getting detections from all the pieces.
Yeah, so we got detections. So, but things were in triplicates and they were sent to each lab for
And I
special
assume
testing.
you used more than one dress, or
Yeah.
more than one.
Yeah,
How
it's 3
many?
dresses, for
Three
example.
dresses.
Yeah.
Three.
Yeah. Yeah.
Can I ask a question? I have to go to finance, so I know it's a little off your topic, but can I ask it before I have to go? So obviously, this fabric has a ton of chemicals in it. My one question is, more so than the average thing I would buy at Ann Taylor, because to make this fabric not wrinkled, not do this, not stain, obviously there has to be a lot of extra things, like the surface stuff put into it. Because then why, for instance, like myself, would I react only to this uniform and nothing I've ever worn before?
Yeah.
Is that chemical levels, can it be higher than the average garment? And number 2, and even though these chemicals are below the standard approved amount, because they are chemicals, can individuals simply have allergic reactions to them because they are not in most other fabrics, for instance?
So all the chemicals we look for are, we expect in clothing, whether you buy it at H&M or Nordstrom or whatever. So what we're seeing here is nothing unusual. We didn't see anything.
The concentrations of the chemicals were not higher than
Not
other
higher.
fabrics?
If anything, they tend to be a bit lower from what I've seen. I've seen some off-the-shelf clothing things to be higher in certain levels. So I can't identify a group of chemicals that are so unique to the Delta uniform that are not necessarily out in comics. And if you're going to follow the OCOTEC type standard, you sure don't want to have any of these chemicals in there, like like a bunch of compounds that I could talk about. On the sensitive population, I think we addressed it in a very specific way, and I'll get to that. But the overall conclusion I have, on a population base, okay? I'm not looking specifically at you and your medical history. I'm not looking at you and your medical history. I'm looking at 24,000 people. And I want to be thoughtful to making sure I don't omit sensitive, what we call a sensitive population. In other words, people that are more sensitive than the average person. And we did address that, and we addressed it by the immune system reaction, because that's a sensitive way of looking at that. So that's kind of I know you gotta go, but this report does cover that from that perspective. Okay, so then we got all this data, and by the way, you might say, how come it's taken so long since you started in May? But I mean, gathering information, gathering all this technical information from Land's End, who they had to go back to their folks on what chemicals they used in the production of the textiles, and they funneled it all up to us, looking at the Bureau Veritas data, analyzing that, deciding to put a chemical program, a laboratory program together, getting the labs organized. It just takes time. And when we finally sent the samples, which was the end of June and 1st of July, it takes the labs, and we told them, do it fast. It took them 6 to 8 weeks to get through all the number of samples that we sent them. I mean, we really sent them a lot of stuff to look at. It just takes time. And then we get all that data back, and then we got to crunch that data into understanding what we got. We started looking for different possible outcomes, like some relationships and stuff like that. So that just takes a lot of time, and then to write it up takes time as well. So that we did it as fast as we could. I certainly wish we could have just, like if it was CSI TV, we could get a DNA sample in 10 seconds. That doesn't really happen in World. This is what it takes. So we get this data back, and there's a couple of things I want to talk to you about how toxicologists do their work. One of them is this idea of what's toxic and what's not. And here I think the media doesn't do a very good job for us, but I'll explain that in a second. Our world is made out of chemicals. Everything in this room, everything on this planet is a chemical. Everything. Even if it's natural, even if it's organic, it's all chemical. If you have an organic farm with an organic sheep eating organic grass, the soil that the grass is on has metals like lead, cadmium, nickel, whatever you want. If the sheep eats the grass, it goes into their system, it goes into their wool. And if we analyze the wool in an organic sheep on an organic farm, we're going to find metals. We're going to find heavy metals. That's just it. The question is how much. It's the dose. It's the dose. It's how much. So, is water toxic?
In Flint.
Huh?
In Flint.
Right?
In Flint. Drink too much, you can die. You can.
Regardless of Flint.
Intoxication.
It is.
Yeah. Yeah.
It's the dose.
Too much of it.
Is oxygen toxic?
The dose.
It's the dose. Excellent. And if it's sarin gas, which is a nerve agent used in chemical warfare, it's the dose. So what's important for us is to identify the chemicals, but then we have to figure out what the dose is, because once we know the dose, then we can make determination as whether or not there's enough to cause a health effect. Okay? So we take all the data that we got from all of the chemical analysis, and what the laboratory tells us is what's in this fabric. And remember, brand new, it also includes little chemical magnets, so to speak, pulling chemicals out. So we pull out more than normally would happen at higher concentrations than would be by wearing the uniform. Now we compare that data to a health effect or to Okatech standard. The health effect, what did we look at? Skin, respiratory. On skin, we looked at 2 endpoints. This is where this sensitive population comes in. We did it for respiratory as well. Is we looked at sensitivity or contact dermatitis. Fancy words, but they really are different. The sensitivity is about your body producing antibodies to a chemical. You can also get alert. Some people talk about allergic reactions. Same idea. You could be allergic or sensitized to peanuts. You could be sensitized to dust mites. You can be sensitized to a bunch of stuff, right? But in the chemical world that we were looking at, there are only a limited number of chemicals that are sensitizers. So Okatech looks at a bunch, but we thought we needed more. And what we did was we looked at the world's literature. And it turns out that the Scandinavian countries in particular, or the European Union in general, are really at the top of the game on chemicals in textiles. We looked at that and we said, we're going to include more than Okatech. We're going to add, I think it was 20 of those individuals. Then we looked at the list of the chemicals that we got from Land's End in the manufacture of it. And we said we're going to pull more chemicals out of that because we think that those need to be tested as well. They're all sensitizing agents, okay? It's above and beyond what Okatech does. So that's something that we did because we think that was important, because this is the cutting edge science right there. We also then sent samples to the California lab where they tested aldehydes that are coming out of uniforms. Again, brand new uniforms, highest concentrations. They sat in the solution. We were measuring as much as we could. And we did detect aldehydes because they're used in the production of textiles. And formaldehyde was detected. I'm just going to tell you it's been detected. So the question goes back to dose. What's the dose? So on the sensitizing agents, we looked, and we think this was the best way to talk about the risk, was to say, if you're already sensitized to zinc, I'll just use zinc, what's the probability that you will get a reaction to the zinc that we detected in the uniform? What's the probability? So we're talking about the most sensitive individual. Someone's already sensitized to zinc. And here's the results. And why do I say this? Because out of the 30 that we picked up, 3 came back, detected zinc, copper, and titanium. Okay? Zinc was the one that gave us the highest risk, so to speak. Here's the numbers. If you're already sensitized to zinc, and we had 20 people in the room that are already sensitive to zinc, 1 out of those 20 exposed to the highest zinc concentration in any part of the uniform. You see what I'm saying? I don't care if it was the men's vest or the woman's scarf, whatever the highest was, we use that number. And we compared that to this endpoint. So for zinc, 1 out of 20 that are already sensitive to zinc would have a reaction. If you were in the general population, so that means you're not sensitized to zinc, the number goes pretty high. It's like 1 in 10,000 or 1 in 20,000. That's the probability of having a reaction, skin reaction to zinc. Now, as I said earlier, why is zinc there to begin with? It's there as a part of an antimicrobial. We know that was put into it. One question we asked ourselves was, we think people would know that they're already positive to zinc. Why is that? Because zinc is in about everything that we are consuming. They're in personal care products, like if you buy like a antimicrobial to put on a cut, some of them have zinc, some are just zinc based. If you put sunscreen on, some sunscreens have zinc. And zinc is an essential element to make some of your metabolism in your body go. So we think that would be the case. But is it possible? Yes. Is it probable? 1 out of 20 if you're already sensitized to it. Does that make sense in terms of how we're doing this? If you look at copper, again, copper is part of one's daily diet in a way, but the numbers are much lower. If you're sensitized, we anticipated 1 in 1,000. If you're already sensitized to copper, you have 1 in 1,000 people that are sensitized. And if you were in the general population, I think it was, I don't have the number on the top of my head, but I think it's something like 1 in 25,000 probability. And for titanium, titanium is, again, found in a lot of consumer items, sunscreen, also in food. And the estimate, if you were already sensitive to titanium, which is very rare, it's not a very potent sensitizer. I think it's 1 in 100,000 if you're already sensitive to it, and if you're not, it's over 1 in 1,000,000. So zinc was the highest, if you will, the most probable for those that are already sensitized to zinc. Any questions on that, or what I'm trying to say?
What was the number on zinc? You didn't give us that. 1 in what? If you were sensitized.
If you're already sensitized, 1 in 20.
1 in 20.
Yep. Okay, so that's. Any other questions on the sensitization?
How do you determine the endpoint of the general population?
There are medical studies in the literature that we used, and they're cited in the report.
So how many total chemicals did you find in our uniform?
So, I'm having my office count the number of chemicals right now. I've been saying over 200. I kind of grouped classes of chemicals together and counted them as one. So I'm asking them to separate that out. We're over 350 different chemicals that we tested for, and I think it's higher than that. And we're testing chemicals that are commonly found in textiles. It's not like we're just doing a random. We were very precise. We were surgical in our decision, but broad in our types of chemicals. So that's, I think that answers.
Did you test a combination of the chemicals together with sensitivity?
Yeah, so let me talk about the ones that are coming out of the jacket, because that's where there's a lot more potential for chemical mixtures. So we actually did this, which we think is a good way to do it, is we took all the aldehydes and added them together and did the same kind of thing we did with skin, but we tested the sensitized population and the general population, but we added all the aldehydes together. So formaldehyde plus acetaldehyde plus crotonaldehyde plus a bunch of others that we did. And then we did this. We put an ensemble together for men and women. I think just for men it was blazer, shirt, tie, pants, maybe vest as well, I can't remember right now. And for women it was a dress, scarf, what else would you put on? But there's like three, huh? Sweater, thank you. We put that together. I knew there was something else. And then we said, okay, so we got men, we got women, we got ensembles for each one of them. We took the highest levels that were emitted, we added them all together, and then we have the health endpoints of sensitivity and then just respiratory disease. And then we asked the question, what if the person was sitting or standing, would that make a difference? So we did it in both. And then we asked the question, is there a difference between people, let's say, being in a house versus being in a public area versus being in an aircraft, commercial aircraft? See what we did? We kind of added a lot of scenarios.
Did you add altitude? Pressurization?
Can I come back to that?
Yes, sir.
Hold on to that. So we added it all together, and the highest risk, so to speak, the highest probability, if you will, was the male ensemble, the man standing, as I recall, in a house. That was the highest exposure to that person. Same with the female, but the female was less than the male. The lowest was the commercial aircraft. Why is that?
A lie.
What's that?
You're in a confined cabin. You don't think that's less.
Which one? The house or the commercial aircraft?
The commercial aircraft.
No, but that's the lowest risk.
That's what I said.
Your
Right,
question.
you don't have all the other essentials coming in. You don't have the EMS coming in or anything like that.
Okay. No.
Okay.
The reason is because the air exchange in aircraft is a lot. It changes within minutes. Complete air exchanges. Half of the air on an airplane that comes in is dumped off, and it's then replenished. Okay? The least is your house, because you've got construction to, you've got cooling in the summer, you got heating in the winter, you don't want stuff to go out your window, so it's closed, so the air exchanges are much less. And with that, you get higher concentrations. Does that make sense? Altitude. Altitude and the working at different altitudes and different pressures and different things is a very fascinating area. So like with the F-18 pilots, they are going like this, and they're pulling G's, and they're doing a whole bunch of other stuff. So I'm pretty familiar with what that is, and there is nothing that the altitude, so pressure, and at altitude you have lower oxygen, right? Because you're at 8,000, you basically pressurize the cabin to around 8,000 feet. So the oxygen tension in the air is a little bit less than here it is on the ground. And then, but those two things do not affect toxicity in the body. Are you getting other things in the cabin? Yes. The humidity is very low, right?
You're saying altitude and pressurization do not...
I have not seen any studies that demonstrate that there's increased toxicity from that.
But in this particular, you didn't test it in this particular study?
Did we test it in this study? No. I don't know how you would test it. Maybe I'm not following your question.
So you said that somebody's standing or sitting in a house, or standing or sitting in a public area, or standing and sitting on an aircraft. Did that aircraft take off?
No, it would be the air exchanges in an aircraft while it's flying.
What ratio did you use?
I don't remember offhand. It's in the report.
Not with altitude.
It's
The air exchange. The air exchange, right? Not the altitude, just the air exchange.
Just the air exchange, yeah.
So no altitude or pressure?
No.
In this study?
Okay.
Yeah. Can you ask your question? Because I'm not sure I'm tracking you.
Oh, I think I got you.
Okay.
Yeah.
Okay. Do you have a follow-up question on that?
Well, you said, if I understood you correctly, and you can clarify for me, you did two different types of testing. One was for emissions.
Yep. Stuff coming out into the air.
And you tested that, you didn't, you cover that process?
No, what he's saying is anything that would be in the cabin because you're releasing the air.
That's what you're talking about.
My question is, so when you had the test samples, you put them in a solvent to extract the chemicals.
Yep.
Did you do a test in which you were testing if there was any off-gassing?
Yes. Yeah. That's our California lab.
Okay. And did I miss that process?
I think so, because I was talking about the ensembles.
Okay, so that was done in a gas,
Exactly. This is about breathing air in.
Yeah.
And maybe I wasn't as clear. So these ensembles is about breathing air into your body.
So what was the process for testing that? So I would assume
In the laboratory?
Yes.
Okay. So we sent the lab pieces of fabrics. They put them in jars with materials to pull out chemicals, and they would gas off, and they would go to the top of this vessel that we had each sample in, and we would pull the gas, the gas out of the top of the container. Very sophisticated, but very good way of doing it.
But done at sea level, or at where
this
lab level was done?
Yes.
It was not pressurized?
Nope.
It wasn't?
No.
Okay, that's my question.
And my answer is, I don't think it would have an effect. But that's my answer.
So what is your response to all of the complaints about our current uniform and the doctors that we're working with?
Yeah, I'll get to that in 1 second. Okatech. So let me finish my presentation. So Okatech had, we sent samples to Okatech, to Germany. They did the Okatech's analysis, just like they're supposed to. We got all the data back, and every one of those that came, except for one, came back below the Okatech standards. Everyone except one garment. That garment is the apron.
That was my reaction.
I'll be honest, I've never worn that a day in my life, but.
It feels like there's
You
a bunch
didn't,
of chemicals in it. That makes
you didn't
sense
read the
to me.
email?
The apron.
Well, it had one chemical in it.
Yeah, that's
I mean,
what-
there
I
were
took
other
excerpts.
detected, but there's one chemical that made that garment unacceptable by Okatech.
That's why we're not Okatech certified, that garment.
Well, Okatech certification, I mean, you all can answer that question, but that was not done. I required the testing of using the Okatech on the materials to get that information.
Gotcha.
So everything passed except the apron. And the apron had one chemical in it. And I'll give you the acronym, PFOA. It's a fluorocarbon. And Delta made a decision, and I looked at it from skin and respiratory, and even though it's above the Okatech, I don't see it causing health effects, but it's above the Okatech.
Gotta go.
Yeah. Does that make sense?
Mm-hmm.
All right, so those are the results. Now to your question. I mean, I think if anybody looks at the work that we're doing, I hope I'm conveying this well enough. I mean, I only have this amount of time, but I hope I'm conveying it well enough about the rigor and the thinking that we did in order to do this testing. We thought about it and we worked really hard to get the results that we did. And if you ask other toxicologists that are trained like I am, they would do the same process. This is the process the government used. It's the process the European Union uses. So all of that is done this way. There's nothing, nothing unique about it other than we just put a pedal to the metal and did it as hard and as quickly and as thoughtfully as we could. And as of today, that is the best science. Okay, that's the best science. What could happen in 10 years from now? I don't know, right? Anybody can predict the future? Because we'll take you on our team if you can predict the future.
Yeah,
but based on all the science we know, I'll get to you. Based on all the science we know, this is the best scientific information, including adding 30 chemicals that are not normally added to this testing. Plus this kind of, what we do as toxicologists is, if we're gonna err on the side of protecting public health. And I've given you several examples about how we do that. All that said, could we have missed something? It's possible, right? I don't think it's probable, but it's possible. Because no one knows anything for certainty. No one ever knows anything for 100% certainty. So one of the things that we are adding to this process is patch testing. But specifically, because what we can do, we've taken pieces of the uniform, we've partnered with a kind of pharmaceutical company that puts it into actual patch testing kits that physicians can order. It's not contaminated, they're the brand new uniforms, blah, blah, blah. If you come positive after taking that patch test, there's something there that we haven't found or we didn't look for. That's a possibility. That's the way to answer that question. So we used our best science, we have gone above and beyond in terms of a scientific approach to this. But we also wanted to be sure that there's another opportunity just in case something somehow is missed, and that's where our patch testing comes in. Does that make sense? Your question?
Yes. So are you familiar with testing that's done by intramural provocative neutralization?
I've never heard that.
Okay, you need to do some research on Dr. Ray. He does that, and I've actually converted the uniform into an antigen and tested. That specifically tests only the uniform in a controlled environment. So if you'll look into that and see if you can.
Can you write on a piece of paper? I'll take it.
See if you can do some more testing along that, because that actually tests the uniform with each person and their individual sensitivity, because I'm totally familiar with sensitivity, and every person's different. You can have the same product, they can both be sensitive to it, but the reactions, because it deals with our nerves and neuropathy and all that, will be different.
Well, can I somewhat answer that question? We looked into I'm familiar, I think, with the process, but I'm not sure. You may have something completely outside. We looked at the possibility of using extracts as for patch testing, which is another way to do it. We felt that it wasn't as inclusive as having the actual fabric on the skin. I am always, I'm willing to be open-minded about other processes, but we actually looked at this one very closely. Building antigens, because that's what you said.
Well, that's
doesn't
now
make
listen,
sense.
I'm not a doctor, but what it does, it actually converts. It actually converts it into the antigen to do subcutaneous testing.
That might be similar to what I'm talking about.
So basically, you'll go in
I know
and
what you're.
okay.
So just give me the name and
Yep.
I'll take a look and double check on
Okay.
it and see what you're talking about. Yeah.
I think that probably is close to addressing one of my questions, which is if for people who are not showing symptoms externally, but internally, a patch test is not going to.
When you say internally, what are you speaking of?
Respiratory issues, cardiac issues.
Cardiac, I think, the doses are insufficient to cause that big of a thing. That's my.
There is no test, I'm not asking for your opinion on
Okay.
what you, if you think is it, I'm asking about the test process. Is there a test
For
that would address testing the uniform for
Other
with an
issues.
individual? A patch test works fine for contact dermatitis or any sort of testing. Like,
For internal.
like an off-gassing test, that sort of thing.
I mean, off-gassing we did test for, so you have that data.
Not
And
the data with an individual person, like you have developed a patch test that an individual, excuse me, not person, an individual could use if they are showing outward dermatitis.
Respiratory or skin reactions.
Is there a specific test that can be administered to an individual if they are exhibiting internal?
So here's the best way to address this. You have my report. You have the Intertox report.
We don't, it's on the screen, and that was my next question, is how can we get a copy of that we can take to our doctors as they have suggested? We can't print it here, and
Okay, well, just hold on to that question. I'm sorry.
My question is there a test?
Okay, thank you.
Is there some sort of?
Thank you, I got it, I'm back on track. So what I would recommend is this. On an individual basis, like, let's say it was you, for example. You take our report and you give that to your physician. Why? Right now, no physician has this data. This data is a valuable set of information for which a physician they can read this is in their language, they can take this information and process it and help figure out the issues that may be going on into someone internally. And then the test that you're talking about will be then developed, would be administered by the physician. That's the way to do it.
Administered by the personal physician.
Right.
You're talking about the 1,000-page
Well,
report?
okay, so you can take, I don't need you to take 1,000 pages to your physician. The text, there's an executive summary that's 5 pages. You can take that, or you could take the bulk of the report, which is about 60 pages. But, you know, physicians, it's in their language. I've taught medical students, this is what they're taught, so.
So on the report, I'm getting the report. So printing is disabled right now out because of the size of the report, but we are developing a process if you wish to have a printed report or the downloaded version. HR is still working on that process. Honestly, the part of the communication yesterday was held up because they were having a problem because of the size of the document. But no, because that is one thing we absolutely want that report available for the individual employees that are having these type of reactions to be able to take the report to the physicians. So that is a priority to get.
Yes.
Like a little question. So you tested for the gassing. So if we breathe it in, what that would do. You tested for on our skin.
Yep.
And this might seem out there, but it's really not, because I've tested positive for ink in my skin.
Okay.
Like I had a tattoo and I have no tattoos. Have we tested what these do to us in our bloodstream?
Yep. Good question, and I'm glad you brought it back because I totally had forgotten that you'd asked about this dye going onto skin.
Yes.
So clearly, I mean, I've seen pictures. It's getting on skin. So let me separate that into two categories. One, I have knowledge, the other, I have no knowledge. I don't have any knowledge because I'm not a textile chemist. Why the uniforms are crocky. I guess that's the term that's being used right now. Why the dye is moving from the uniform to the skin. It's clear that that's what's happening. I've seen pictures of bed sheets, I've seen pictures of pillows, I've been, people saying that their toilet seat is colored.
Yes.
Breast milk.
Even
All my
years
white
after
clothes.
washing.
My watch, I have them now.
Yes.
So I get it. I mean, that is frustrating from that standpoint, but I don't know why that's current. Does that make sense? I don't know why that happens.
But is that toxic?
There's the question.
Well, so there's, so the other question was dyes is
Let me
different than
finish.
chemicals.
Let me finish with her. So we tested the dyes, and they were either non-detected, or if they were detected, they were below the zinc level.
Okay.
So from a health standpoint, that's not the case. Now, I've also heard, because of the opportunity to meet all of you, not just you, but other people I've been meeting. Well, my lung fluids, my lungs are turning purple, or the things in my feet are turning purple, or my breast milk is purple, or something like that. And it's not, here's what it's not. It's not the dye going into your body and being distributed through your bloodstream and then being sweated out. That's not it. The molecule is too large. And again, if anything gets in there, it's going to be metabolized and excreted. So why is it in those things? I think the uniforms are releasing the dye. It stays on the surface of the skin. And when you wash or whatever, it gets off. That's my best answer, but I'm not an expert in that.
But into your breast? Like it's going through the nipple?
I can't see that going in. And
So
Weird.
on the first purple breast milk, because when that first we were made aware of it was of course very concerning, right?
Yeah. Huge concern.
And what throughout all of this that I would challenge you guys to do, and what is not look through these problems with a very narrow scope, right? Is you've got to look to see, is there any other plausible information? And when we actually did the research on the purple breast milk has 5 unique colors, depending on the duration from the time that a woman gives birth through the phase of breastfeeding. We looked at that one individual who made that specific, and when you do the math on when she gave birth versus when that milk is the exact same time that breast milk would be known to have a bluish tint. And so I do think that there is, and we have heard the purple breast milk over and over and over again, that I would just use caution with some of those type scenarios, and not necessarily look through a very narrow scope, right? Is look and ask a medical professional the feasibility of that. Could it be feasible? And what we are hearing time and time again from Dr. Pleus and others, that with the dye transfer, the answer is it is highly improbable that is in fact going to be.
There's some other physiological components in breast, when the breast is producing milk as well, that the cells that are producing the milk are pushing, the pressure inside the breast is pushing stuff out, not sucking things in. I mean, that's another, just a simple example as well besides the skin. In other words, the cells that are actively producing milk are pushing milk out, as I'm sure a lot of women know. Yeah.
So beyond the milk thing, and you guys tested both dresses, right? Not just one of the dresses. Yes. Okay.
All of the dresses,
all of the dresses,
in
right.
in the catalog.
Okay.
So think about it. The only items that were not tested were the 3 outer coats.
Right. Okay.
All the scarves, everything that you would wear on your body,
And the gloves.
the gloves and the coats, the outer coats were not tested. And the
Pink
mitts.
and our regular, or
Pink,
just the
yes.
okay.
The BCRF dress was also tested.
Okay, so when we first got them, all I wore was the signature dress, and that was the main culprit for the purple underarms, which I didn't think anything of. 2 months into it, and I worked an average of 120 to 140 hours a month.
Which is an extremely, it's a high.
Yes, it's very high.
He doesn't know flight attendants, we have to help him with that.
Oh, I was getting it out. So I was in a car accident, and I went to the hospital, everything, and like I said, they drew my blood, and there was a lot of ink in my blood, and like I said, I have no tattoos. They thought I had a tattoo, so then I was like, okay, whatever. Go back to work a couple months later, start wearing this dress because something with the wings with the other dress, the wings actually broke me out. But went to go give blood, and they said I had to wait 6 more weeks after my tattoo that I'd gotten, that I don't have a tattoo. And so then I went to the doctor, and our underarms, they pull things in. That's why you see all these things about not wearing deodorant or wearing natural deodorant because cancer and all that stuff. So right now, not having health problems, but knowing that I'm getting ink in my blood from certain of these garments under my arms, but not having health issues, like because I'm a healthy person, but knowing that the only way that I could be getting ink is from these uniforms and working so much, which I love to work, so that's not going to change. In 10 years, like you said, the future, we don't know the future, but I don't want to see a commercial. If you were a Delta Airlines flight attendant between the years of blah blah blah, call our law firm. You're entitled to money because you're gonna die in 2 years.
Right.
So my question is, in testing, are we going to further test the long-term effects of not just the ink transfer? Because like I can prove that it is the ink transfer from the signature dress, which I don't wear any longer. But like in any of this, the long term, I know you said dosage. I was getting a high dosage of everything because I work so much. That's not going to change. But with saying that it's not toxic, that could change the options of me coming to work because of not being able to wear something different.
Yeah.
If that makes sense.
It does, and part of, I think I've answered my part. I don't know if that's, what she's asking is not so much science, but.
Are we going to continue to see the long?
Is the extended, what, is there, because you are in the uniform longer, are you having a higher dosage of the chemicals, whether it is the airborne emissions or
anything
via skin?
Well, the aldehydes are not coloring blood. I mean, that would be it's what you're talking about is a dot, is what you're really referring to, because none of the other things have.
In order for her to have ink in her blood.
Yes.
I mean, from just as a specialist in that area, because what you're saying is, you said you've got medical data. I don't know how you bring that into the system, but I mean, I am skeptical, but I'm open-minded about, because as I said, when we looked at the dosages and when we looked at the size of the molecule, it doesn't make sense.
Mm-hmm.
Would there be any ability to take her blood test results?
That's what
well,
I'm
I'd have to
suggesting.
start wearing the signature dress again.
Yeah, but you had
the original.
You said you had tests.
Yes. Mm-hmm.
Right.
Yeah, if you had those tests, I don't want to I'm not looking to do everybody's analysis here, but I mean that sounds.
Well,
I'd be happy to look at them.
I just want to know the long-term effects. Have you guys tested the long-term effects of any of this stuff? The long-term, not just okay, it's not toxic right now, but we're going to be.
Is it possible to do long-term effects?
Right.
Well,
they're not admitting that it's happening.
So
they have to
if
test it.
Exactly.
well, the doses. I mean, again, the doses are pretty low, but have we looked at the super long-term effects of these compounds? It's part of it is
of
not
the compounds,
not possible on many of these things, but we could take a different look at it and see what we know about some of these compounds.
Are we going to is the question. You're saying that we can. Are we going to? Is Delta going to? Are you going to?
If they pay them enough.
And I think that that's something that really we're gonna have to take in. That's not something that I think we can answer here.
Okay.
You know, and I will stress this, that now that we have the report, we can't solution this ourselves, nor can you solution this yourself.
Right.
This is where things like the ink in your blood is having that medical for us to cross-reference, to try and, because we have asked all kinds of questions about what is the feasibility and could this medically occur. And so we have gone to experts and we have gone to people that are very knowledgeable in their field to try and answer these questions, because we as a leadership team, we are concerned about what is happening. And we have invested a lot of resources to try and get down to what the problem is in trying to work with individuals. And really this is, as we move forward, now that we have the toxicology report, is looking at each individual who has reported and what do we know about that individual, and asking that individual to take that doctor or take that report to their medical provider, to use the data and to use what's in the report to try and then associate what is happening with the individual to try and resolve what the issues are. Then coming back, using that from a medical professional, because I've had a lot of complaints about why are we having you try all different uniforms, right? The whole wear test. This is where, if we don't know what the individual is reacting to, we can't offer a uniform solution, right? That's where we need, and I talked the teamwork, we need medical documentation to tell us what the reaction is, for us to be able to go back then to see, is there anything in the collection that we think will work, or do we maybe need to look for another solution? But we're right now kind of just throwing spaghetti at a wall with individuals not necessarily having that leeway on the medical. We can't do this alone on what it's going to take to resolve the individuals who are having the reactions. Does that make sense?
Okay, so I have a very specific question. You mentioned when we were talking about crocking, there's some part of it that you know, and the part that doesn't make sense to you about the crocking.
Right.
And you said, but I'm not a...
Crocking,
you
textile chemist.
Textile chemist, okay. And then my other question is, my sister is a cardiothoracic surgeon at Emory, and so she has looked over, I'm lucky enough not to have any issues with the uniform other than your same issues. Very lucky, and I feel so sorry for everybody who's having those issues.
Yeah, I agree.
That being said, and I think when I came in you mentioned, yes, I'll admit it, there's formaldehyde, so I think I forgot the formaldehyde expression, but that is my sister's #1 concern, to the point where she is like, you shouldn't be pregnant in this uniform, I don't want you around my babies in this uniform, because of that formaldehyde. And there was the infamous, there's less formaldehyde than a banana email, but really, and I told her that, I said, well, apparently the formaldehyde is not that bad, and she said, no, there should not be any formaldehyde ever touching your body. And all the patch tests that have come back, it's showing people allergic to formaldehyde, because everybody has a reaction to formaldehyde. So is the formaldehyde being taken out of the uniform?
Well, I need to correct you on a couple things. Number one is, there's no humanly possible way to not be exposed to formaldehyde on this planet.
But on a daily basis in our uniforms, I guess is what I mean.
No, not even, I mean, forget the uniform.
No, you can't.
Just living on this planet, we're exposed to formaldehyde on a daily basis. If you drive a car, if you live in a city, there's formaldehyde.
If you sit on furniture.
Yeah, absolutely, but we're talking about
house.
doses, right? Too much formaldehyde, and having something that has formaldehyde in it that we're wearing every day to work 120 hours a month.
Again, it's about the dose, okay?
Will it ever wash out of our uniforms?
Yeah. So, but again, let me finish and then I'll come to your question.
Okay.
So, your body makes formaldehyde, by the way. Okay, so
yeah,
that's...
she explained that to me too.
Okay, so that's important.
It's the adding, you're adding another dose in the uniform.
again, from a perspective of all the things that one is exposed to, your uniform isn't producing so much that it just it's the last, whatever you call, what's the metaphor? The last straw on the camel's back or something like that.
Straw to break the camel's back.
Thank you.
So there's no plans?
Well, that's a, you're asking a
Like
scientist.
chemicals.
You can ask your company whether they're gonna include that or not. That goes to Lands End. That's a different question. Just like with Okatech and the apron, that was a decision by the company to make that demand. Does that make sense?
Mm-hmm.
But when you're on airplanes or when you're coming to work, you're gonna be exposed to formaldehyde.
I understand that, I'm talking dose, because it's another dose.
So back to her question on the dyes.
Yeah.
Because you tested for metals.
Yep.
You did not test for dyes, is that correct? Or you did not test the dyes?
We did test the dyes.
You did test the dyes.
What did we test them for?
For the sensitization.
Okay.
Primarily, because that's the most sensitive endpoint.
If people are allergic to that.
Right.
But did you test the effect that the dye it can have on the skin or in the bloodstream?
So on the skin, just directly on the skin?
Yeah.
I don't know the answer to that, but specifically, but I have no indication to say that somehow it's affecting the top layers of the skin, other than it sits there. And when you put, clothes on and stuff, it'll come off. Okay. That's what's happening.
And do we test it that it can come through the skin, that it is, because it's not ever disappearing, because it's not ever being completely washed out, because every time that you wear it, it touches your skin, right, and it's left on your skin. Right. Did we test, is it getting ingested, for lack of a better word, by our skin?
So we made the assumption that it does.
That it does, okay.
So that we made that assumption. I don't know exactly the answer, other than we said, let's assume that it does. What's the level that would cause this immunologic reaction?
Yeah.
So we did that.
Okay, so for an allergic reaction,
yep,
but not if it is unhealthy for us to be in our skin. You know what I mean?
Not unhealthy to be in your skin?
Like an orange. It's on top of you. You take an orange juice, you rub it on you, right? It has no effect. You drink it, you get vitamin C.
Right.
That's ingested.
Right.
The dye on our skin, it has no effect. But inside of us, did you test to see what it does?
Well, the only way
to test that?
I'm not trying to be facetious here,
okay,
but the
no
only
problem.
way to get it in your body that way, eat your uniform.
I feel like that's what my armpits are doing.
I don't think that's happening, but if it is, then we can have another conversation.
Okay.
I have a follow-up question to that, because you're saying that the actual chemical makeup of the dye is it cannot permeate the skin because the molecule is larger than the...
It's large, and that slows the progression down. Okay, that's what I'm saying. And I'm saying, let's assume it does go in. What is the level that would cause a health effect?
And can you explain to them how you have an answer for that?
I just did. I'm not trying to...
I'm a little confused, because you told her the only way it could get inside is if she ate the uniform. Yeah. But now you just told me that it slows the process, but the molecule is not too big to actually permeate the dermis.
Okay, so let's start at zero.
My actual question is that, and I hope that you can answer this, because I wear the uniform on my body, don't wear it on my head.
Yep.
I'm taking showers, and when I take off the uniform, complete showers, wash my hair, I'm getting dye on my pillow.
Yeah.
Now, I don't use a pillow anywhere except on my head. Not wearing a uniform on my head. How can I explain that transfer?
I don't know how to explain it, other than you're not sweating it. I'm saying that when it's on your skin, the molecules are large, so they don't transfer through that epidermis. I'm saying that's true. And I'm saying, if it did, the dose that's in isn't sufficient. that's the science answer. I'm not trying to talk around it. But that's the best science I have to help answer those questions.
When you talk about dosage.
Yeah.
What is taken into account? Amount?
Yep.
Length of exposure?
Yep.
What?
All of the above, yeah.
And what were the numbers that you used?
Concentrations in the fabrics, right? Pulling the chemicals out, highest concentrations.
No, I mean, what was the duration of time that you had us in uniform?
8 hours with the, in the bath of the chemical that is the chemical magnet.
Okay, duty day is 15. Did we do 15 hours?
No.
For 7 days.
Could that change it? Yeah, could that change it?
I don't know the answer to that question.
That's what my formaldehyde thing was mainly saying, is like, okay, it's not gonna be the straw that breaks the camel's back, but it's certainly not helping.
Yeah,
You know
8
what I mean?
hours is typical of a 9 to 5
Being how long
job,
we're in our uniforms
not
and
this
we're
one.
sweating and the planes are so hot,
Mhm.
and all of a lot of people's symptoms came about during summer.
Mhm.
Yeah.
You know, could it be, and you talked about it being a synthetic sweat, so could it be sweat? I mean, I drip sweat during boarding
I'm sure
and
it's
things.
sweat. I'm sure that's the transfer, that's transferring from the uniform to the skin. I'm sure of that.
And don't our pores open when we sweat?
They're releasing stuff out, so the pressure is coming out, not going in. Does that make sense?
What if somebody had a gash on their armpit? Say, one
We
the
shave
teams
our
didn't
armpits.
agree.
Yeah, no, seriously.
We shave. Would that be a big enough entryway if you had a visible gash that would allow the passage of those molecules, perhaps?
Yes.
I think if there's a big enough open wound,
Mm-hmm.
that's gonna, so all the stuff I talked about with the skin, the layers, then that's a different story.
That
If
would
there's a-
negate
So
all
your
of
skin's
that.
not protecting you,
Yeah,
and
but I
it
mean,
might have the passageway to become more internal.
it is, and that's why I say, when we looked at this from a predictive standpoint or risk standpoint for getting it in your body. So we're assuming it's going in, even if there was a gash or whatever, we're making that assumption. Okay, worst case,
I don't know if
highest
the
level.
intake process, if there would be different effects, like if you were just kinda like drooling and you like kinda suck some in, or we all take crew rest, we all drool.
We know for a fact that it's happening, right? We
Yes.
know for a fact that we're getting out of our uniforms, we're
Yep.
showering, and then
Yep.
for me, when
I
I'm
hear
working
that.
out,
I
I'm
absolutely
ruining
hear
my
it.
Lululemon white
There's no
bras.
explanation
So-
for it being
Yeah.
on a pillow.
So
You know,
it's,
I'm
we
not
know it's
sweating it
happening.
out. It's just.
So
It's just going
magic.
there, and it's a little disconcerting hearing
That's not
that
science.
you don't know why.
So,
Can't be magic,
well,
but-
there, okay. Let me just, and then, I don't finish sentences around here. No, so, in the interim of things, there are factors. Time, I'm so glad that